Hi friends, in this video we are going to see about Floyd's algorithm, which is available in third unit. And for Floyd's algorithm is used to find all pairs shortest path problem. It is also called as this title. So here what we are going this will be similar with Floyd's algorithm, and instead of 1 and 0 we can have values, whatever value we are finding in this graph that have to be mentioned. So first point is this graph is given with weight. So given a weighted connected graph that all the pair shortest path have to be find the distance, the v length of the shortest path from each vertex to all other vertex. From one vertex to all other vertex we have to find the shortest path and it have weight. And for second point is weighted graphs are represented by using weighted matrix. So Floyd's algorithm is used to compute distance of the matrix. So now we will directly move with the problem. This is what the problem we are considering for Floyd's algorithm. So this Floyd's algorithm is used to find the shortest path, all pair shortest path problem. So here we have a graph and with weights. So that will be maintained as weighted graph and weighted matrix. So here what are the values we know? For example, as like Warshall's algorithm, here you are supposed to mention a matrix. From here we have 4 nodes, that is A, B, C, D, and that have to be mentioned with for rows name and also columns name. So rows name A, B, C, D and column name A, B, C, D. So here we don't have any till end we don't have any A to A and B to B, B C to C and D to D values, so we can mention diagonal roots with 0. So here from A I can move to C, so it is from A I can move to C, so it is 3. From A I that's all, and from B I can move to A, so it is mentioned with 2, and then from B I can move to B and C. So from C I can go to B 7 and D it is 1, and from D I can move to A, that is 6, and so first zeros are filled and value weights are filled and remaining things are mentioned with infinite. So this is what weighted graphs matrix, adjacency matrix. Now we will go with next step, that is this is the same matrix will be considered as 0th step. And next, as like your Warshall's algorithm, Floyd's algorithm also have intermediate node. The first node, intermediate node is A. So here we have to check we don't have diagonal nodes, weights for diagonal nodes, so it is mentioned with 0. So from A to B, from A to B I don't have path, so it is infinite. From A to C I have 3, it is already available, though this is what the shortest now as of now, so I mentioned with C. So from A to D I don't have any direct, so it is infinite. Next is B to A. B to A I already have 2, that is mentioned, and B to B 0 and B to 5. So A is an intermediate node, now it is opened. So from B it is it went through A and it reaches C. So 2 plus 3 5. So 5 will be the new path we can identify in this particular matrix. Next, B to D. So from B to D I can't go, so it is infinite. Next, C to A. C to A it is not available, and C to B it is 7, already it is 7, so it is mentioned as it is, and C to D it is already mentioned with 1. So next is D to A. From D to A it is already 6. So from D to B it is not able to do, so it is infinite. From D to C, so through A is opened, so 6 plus 3 it is 9, so it is 9. So D to D it is not available, 0. Next intermediate node is A to A and B are intermediate node. here it is everything is same as the previous one. And for this, so we have A and B, right? So from C it can move to B and it can move to A. So it is 2 plus 7, it is 9. So remaining all the values are same as the previous step. And for intermediate node 3, so here you have all the diagonals are 0 and we can have A to B. So for A to, this is all 3 nodes are intermediate node are opened. So here we have A to B. So for A to B I can go to C and I can move to B. So from this 3 plus 7 it is 10. So I can mention 10 here. And then A to C, so it is direct, I have 3, so it is already mentioned. Then A to D, so from A I can go to C, then I can move to D. So 3 plus 4 1, it is 4, so value is 4. So for B to A it is 2 as like the same for previous step, it is 0 and it is 5, it is the previous as like the previous one. And for B to D, from B I can go to A and then C and then D. So 5 plus 1 6, so here it is 6. Next, this is previous one and these steps are previous. And for this one it is already available, the same value I got, so I mentioned with the same value. If we have any lesser value, that can be updated here. And for this, so D to B, so D to B I can go to D to A to C, C to B. So 6 plus 3 plus 1, sorry, plus 7, so it is 16. 16 is mentioned.